Okay, so here's our second episode of elementary number theory for GCDs and LCMs, which each represents greatest common differences and least common multiples. And if you are a professional mathematician, I still want you not to watch this video. Okay, so now let's begin. For this video, I would like to have three parts. The first part is the definitions. Second part is how to find the GCDs and the LCMs. And the last is a very important part of this topic, the Bezos identity. So here we talk about definitions. So first, GCDs, right? It represents great common divisors. So, there's an important word here, divisor. What's a divisor? For example, just as we talked about in the last video, let's say if A is divisible by B, so write it like that. We also say that B is a divisor of A, right? So, the concept of common divisor is if B is divisible by B, while C is also divisible by B. That means B is a common divisor of A and C. So then it leads to the concept of greatest common divisor. GCDs. It means the largest divisor of A and C, let's say, among all those common divisors. Okay, so for example, let's take 12 and 8, right? The common divisor of 12 and 8 is 4. They also have other common divisors that are like 1, 2, 4, right? So 4 is the greatest. And there's also another rule that all those common divisors are divisors of the greatest common divisor. It's an important thing to memorize. Okay? And there's also a symbol to mean the GCDs. For example, we say the greatest common divisor of 12 and 8 is 4. So you write something like this. You can express in this way. Okay. Now let's go to the least common multiples, LCMs. So now here is also important to explain about multiples. For example, A is divisible by B. So, okay, A is a multiple of B. And just common multiples, just like the common divisors, if A is divisible by B, A is divisible by C. Say like this. Okay. Then that is to A is is a common multiple of B and C. So, of course, the least common multiple is the least one of all the common multiples of two numbers. For example, 12 and 8. The least common multiple is 24, right? They also have other common multiples such as 48, 26, and so on. Yeah, it does make sense. So there's also another way to express those. We write in this way, right? Okay. After talking about the definitions, we would like to get how to find out those GCDs and LCMs. For example, you can find them by instinction, but when meeting some big numbers, it's just hard to find out these GCDs or LCM. So let's introduce a way. Let's take a big example like 60. Clear this. Okay. Right. 60 and 48. So how to find the greatest common divisor of 60 and 48 and the least common multiple of 60 and 48. So first write down those two numbers. Draw something like a big L. So here you need to find one common divisor of 60 and 48 by instinction. For example, let's say 2. Okay, 2. There's also a principle that you should always find the least one. Okay, find the least one. Expect one, and divide it. For example, 48 divided by 2, 34. 60 divided by 2, 30. Repeat. So just 2, 12, and 15. So now, and the least will be 3, okay? 3, 4, and 5. So now the procedure stop because obviously the greatest common divisor of 4 and 5 is 1. So let's stop. And after that, we'll go on and find the GCD. What's the GCD? Look at those numbers on the left side and you multiply them. For example, 2 times 2 plus 3. 2 times 2 times 3. Yes. What does it do? 12. Then 12 will be the greatest common divisor of 60 and 48. And what about the least common multiple? So you just need to multiply more, like add these. Okay, so the LCM is 2 times 2 times 3 times 5 times 4. Okay, so 12 times 20, 240. That's an easy way, isn't it? I think in many schools worldwide they are teaching this method for primary schools or maybe middle schools. There's also a name for this method. I think it should be called short division. Okay, so you have a name for this way to find the greatest common divisors and the least common multiples. Now let's go on. Actually, there's a new way to find the GCDs. The Euclidean algorithm. What does it say? So now let's begin expressing it. For example, you have two numbers, A and B. So let's suppose A is greater than B. So if B is greater than A, you should change the order. That's okay. It doesn't matter. So let's suppose A is greater than B. And let's suppose that A equals B times Q plus R. Here, Q and R are all positive integers. Let's say natural numbers. R are natural numbers. Not positive actually. They can be 0. So let's promise that Q. So as long as A is greater than B, Q is greater than 0. So Q is actually a positive integer, but R can equal 0. R, let's say it must be greater or equal to 0, but it must be less than B. Okay? So for example, let's say A equals 8, B equals 3. So you should now say Q equals 2, right? R equals 2. That's a reasonable thing. Okay, so now let's erase it for our explanation of the Euclidean algorithm. It's something like complicated. For example, I want to figure out the greatest common divisor of 102 and 60. First, we did something like we just said. 102 equals 60 times 1 plus 42. Okay. Here the Q is 1 and R is 42. As long as it's apparently that 42 is less than 60. Okay. So now let's begin on this procedure. But in the next step, the A will be 60 and the B will be 42. Okay? What does that mean? 42 times 1 plus 8. So here the A is 60, the B is 42, the Q is 1, and the R is 8. Reasonable, isn't it? And now let's continue. Okay? Now it'll be 42 and 8. 42. 42 equals 8 times 5 plus 8 times 5 plus 2. Okay. So now the next procedure will be 8. Okay, so that's the last step. That's the last step. We have figured out that I thought we had done something wrong. Oh, there's a mistake. There's a mistake. It's not 8. It's 18. How stupid I was. Oh, it's 18. I thought it was wrong. 2, okay? Weird. Oh. So, okay. It's reasonable now. So after all those procedures, after all those steps, the final B will be the greatest common divisor of the original two numbers. Okay, so now 6. Actually, there's another rule that for all positive integers or natural numbers, we also included 0. If the time the greatest common divisor of the two numbers times the LCM, it will equal A times B. So after you figure out the GCD is 6, you can just figure out the LCM. It's a very convenient way when you compute the greatest common divisors of large numbers. So let's talk about Bezos' theorem. Another theorem is identity. Identity. It's not a theorem. So what does it say? Here's the proof, subtracted from Wikipedia. What to say? For two positive integers, A and B. Okay, A and B. If there does exist two integers, like this it. Oh, AB does not have to be just AB non-zero. Okay. X and Y are integers. Then if AX plus BY equals 1, that shows the greatest common divisor of A and B will be 1. However, we can to say expand this conclusion. We can just view it on this paragraph, and you can just search it on Google or on Wikipedia to find the proof, or even you just, in fact, a proof is possible when you use the Euclidean algorithm. You don't need to use the method mentioned on Wikipedia. Okay? So, I'll be glad if you can make your own proof. This is very important during a study of maths. So Then our second episode is about to end. And for the third episode, I would like to talk some questions related to the greatest common divisors and the least common multiples. It's a very, very important part in elementary number theory. And if you learn about some conjectures, in fact, some conjectures are related to GCDs and LCMs. So it's important. I hope you learn it well and fully understand it. So don't forget, if you like this video, then like it and subscribe my channel. And you can also send email, not this email, egal909 at gmail.com to ask for anything you want to learn about elementary number theory. Okay, and some questions you can ask me. So let's see at our next video.